The project was funded, approved, and ready to install. Then the team discovered the only practical cable route passed through a space technicians needed to reach every week. The technology fit, the building did not. And that is how a straightforward upgrade becomes a redesign, a delay, or an operational risk.
Welcome to Built, Wired, and Secured. I'm Alex Morgan. Today we're asking a practical question. Does your building have enough expansion room for its next technology layer? Michael Harrington and James Rogers are here to help us look beyond the equipment list and examine what the building must provide around it.
Glad to be here. From an operational standpoint, the approval is not the finish line. It is the moment when someone should ask what breaks if this goes down, and what becomes difficult to maintain if it does not.
Exactly. The equipment is often the easiest part to picture. The harder part is giving people a workable route, a serviceable room, stable environmental conditions, and enough information to keep the system useful 5 years later.
Let's use one example throughout the conversation. Imagine a commercial building adding another layer of security and automation technology. The project team has selected the capability, but the building already has crowded pathways and a busy technology room. What should happen before anyone commits to installation?
The team should stop treating the project as an isolated purchase. Property, facilities, IT, security, and the project lead need one shared conversation about where the change lives, what it needs, who it affects, and who will operate it. If those questions are answered separately, the gaps usually appear during installation.
So the first test is physical capacity. But when someone says there is space in the room, what does that phrase actually mean?
It means less than people think. Is there space to install the equipment, and then space to inspect it, label it, remove a component, and work safely without leaning across something else? A clear wall section may look available, but if a technician cannot reach it during a maintenance window, it is not usable capacity.
Usable, not merely visible. What about the pathway?
The drawing may show a route, but the person installing it still has to
Get around the existing services without turning the route into a maintenance trap.
Right, and the route has to remain identifiable. If new work creates a tangle that nobody can trace later, the building has gained connectivity but lost maintainability. Reliability starts with disciplined maintenance, and maintenance starts with leaving people a clear way to do the work.
There is another issue. That room or pathway may be shared. Property may see base building space. IT may see technology space. Security and tenant projects may depend on the same resource. An empty section is not automatically unclaimed space.
Borrowed capacity, then. Borrowed from whom?
Usually from the next maintenance window, or from the next emergency. A project may fit today by blocking access, consuming shared room, or leaving no route for future work. That is fine until it fails. Then the downstream impact reaches the people who never approved the original assumption.
And the person discovering that problem may be the technician standing there with a replacement component and nowhere safe to work. That is when a small planning shortcut becomes a long service interruption.
Now, suppose the room has enough physical space. The next question is whether it can support the electrical and environmental load. If the room feels comfortable during a walkthrough, is that enough to move forward?
No, I would not move forward on that alone. A walkthrough tells you what the room felt like at one moment. It does not tell you how the added load behaves on a warm day, during a cooling interruption, or while another team is performing maintenance. Trust the process. Review the operating history, the proposed change, and the assumptions behind the environmental support.
So the walkthrough is evidence, not approval.
Exactly. And power has the same problem. The question is not only whether the equipment can be energized. Can the building support the added demand with the expected reliability, maintenance practices, and recovery plan?
That distinction matters because tenants feel this immediately. They do not need to know what happened inside a technology room. They notice when access, comfort, availability, or response time changes. What breaks if this goes down? That question should be asked before the added load becomes part of the building's daily operation.
In our example, the security and automation project may work on day one, but it could consume the remaining cooling margin or make routine access harder. That is a different kind of failure than a device not turning on.
Yes, the system can be functional and still make the building less resilient. The best day in operations is the one nobody notices. If every future service visit requires special coordination because the room is too hot, too crowded, or too difficult to reach, the project has changed the operating burden.
That brings us to the capacity people cannot see on a floor plan. Operational capacity. Who receives the alerts? Who knows what normal looks like? Who has time to maintain the added layer?
Every new layer creates obligations. Someone must understand the system, monitor relevant signals, coordinate maintenance, and decide when an issue affects operations. If those responsibilities are vague, the building has added capability without adding dependable control.
And documentation has to arrive with the work. Where is the latest record? What does normal operation look like? What changes were made? And who should be contacted when something behaves differently? Years later, that information may matter more than the original project presentation.
Michael, where does shared ownership usually become visible?
At the boundaries. Property may own the space. Facilities may operate it. IT may manage connectivity, and security may depend on the result. A project team may deliver the installation and move on. If nobody clarifies monitoring, maintenance, change approval, and record keeping, the building has a gap between installation and operation.
And that sounds like the point where a project can be technically complete, but operationally unfinished.
That is exactly it. A technician arrives and cannot find the current record. An alarm reaches a team that does not watch it. A maintenance window is scheduled without understanding another system's dependency. None of those problems necessarily looks dramatic in the project plan, but together they erode reliability.
Let's turn this into a review that a team could use next month without pretending it replaces site-specific engineering. What is the first move?
Bring the right groups together and describe the change in operational terms. What is being added? Where will it live? What does it need? What could it affect? How will it be maintained? Then rank the constraints by consequence. A documentation gap may be repairable before deployment. A pathway that cannot be serviced or a condition that threatens continuity deserves attention first.
I would physically walk the sequence. Where does the material enter? Where does it travel? Where does it terminate? Can people reach each point safely? Then ask what happens during maintenance, not just during installation. Preventative maintenance beats emergency repairs every time, and walking the sequence exposes problems while they are still easy to change.
And write down the assumptions. If the room is expected to remain available, record it. If access depends on a maintenance schedule, record it. If another technology phase is coming later, record that too.
Yes, the review should end with a simple decision. Proceed, revise, or pause for a deeper assessment. If the team cannot agree on who owns the space, who supports the system, or what happens during a failure, that uncertainty is itself a project constraint.
The warning phrase to listen for may be, "We will figure that out during installation."
Absolutely. That usually means an important dependency has not been discussed. Technology should support operations, not complicate them. If there is no maintenance story, the planning is not finished.
Before approving the next technology layer, ask 5 questions. Is there a usable pathway? Is there maintainable room? Can power and cooling support the change under real conditions? Does the team have the capacity to monitor and maintain it? And are ownership, assumptions, and future changes documented?
And ask what breaks if this goes down. Ask it early, while the plan can still change.
That is the shift. Not merely can we install this, but can we operate it reliably? Take one upcoming building initiative and run this expansion room test before the project is locked in. Then share this episode with the property, facilities, IT, security, and project teams who will be responsible for making it work. That wraps up this episode of Built, Wired, and Secured. Today we explored why expansion capacity is more than empty space and why buildings need room to be powered, cooled, maintained, documented, and operated before they can reliably support another technology layer. Thanks for spending a few minutes with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.